In this video, we're going to talk about how to fit a trend line. Here's my data here. You can see in this experiment, a student changed the concentration of HCl acid and measured the pH. The student's already taken the average data, graphed that data, included error bars, and here we have our final set of data. All what we need to do now is fit a trend line. Now, just a thing to notice, just to quickly look at the data first, we can see here that the x-axis error bars are all fairly consistent, but the most noticeably large ones are definitely the y-axis error bars, so we'll try and fit our data through those error bars. Okay, so to start the process, we must go to click on the data points, right click and go down to add trend line. Then we have our choices here. Now in Excel it actually shows us our choices as we go. Unfortunately I can't make this smaller so you can see, but we can see that a linear relationship fits through most of the data points. This one it misses, this one it misses. We can probably see that clearly that the relationship is a little bit curved, and so linear is probably not the best relationship. Next option, we can take a look at logarithmic. That seems quite a logical relationship here. Polynomial is also another possibility. A power relationship, an exponential relationship, or a moving average. Moving average is basically never used in science. This is more of a finance type thing where you look at how the average changes with time. We're looking for a mathematical relationship here, so we're down to a couple of choices here. A logarithmic relationship or a polynomial relationship. A power relationship may fit as well, but still we end up with this point, so I think we could probably narrow it down to logarithmic or polynomial, but we'll leave power in there and see what happens. Okay, so we've got three options here. Let's just have a look at what they look like if we start with a logarithmic one. Okay, now first thing that we can do is go to the options section, and we want to go display equation on chart. This is important because this tells us what the mathematical relationship here is. Now the other option we've got is to go backward or forward a certain number of what it calls, or what Excel refers to as periods, which essentially means along the x-axis. So if I go 10 periods along, I'm going to extend this from 50 to 60. So if I say forward 10 periods, it increases that trend line from 50 to 60. We want to see how this goes the whole way, so we want to go to maybe 100 periods and see that we're getting this situation. So this is interesting. We're getting this situation as we increase the concentration of the acid. We see that the pH decreases and decreases. That actually makes quite a lot of sense, and so we can probably conclude that logarithmic is a valid relationship. Let's go back and let's choose our polynomial. Oh, if we choose polynomial, and notice how we then forecast our option. Even though a polynomial originally appeared to fit correctly or better than the logarithmic, we notice that if we apply the sensibility test and then look at what that relationship means, we can see that actually this one doesn't really make a lot of sense. So for example, we keep increasing the concentration of acid to make it stronger, and we find that the pH goes up. Now this could be problematic, remembering that at pH 7 we have neutral water, so this relationship would say, okay, we're increasing the strength or concentration of our acid and it's becoming less acidic. So clearly the polynomial makes no sense. So we can reject that as a possible relationship. The third option, power, also makes a lot of sense. We can see that if we increase our concentration of acid, then our pH reduces, which means it becomes more acidic. So now I guess we're down to two options. We've got to see which one seems to fit the best. So let's just compare the two. We've got power relationship here and logarithmic. To me, I just think that the logarithmic here fits through more of those data points more accurately. Now, of course, we have got some data points here that don't seem to fit. So here's one example, here's another example, and here's a third example. These data points are referred to as outliers, and essentially they occur because of some kind of bizarre random error um, that goes beyond kind of the experiment. So it could be something that's during that experiment something happened that wasn't part of the rest of the experiments that could explain why these outliers occurred. So outliers can be rejected and a relationship formed. So in this case, I would come to the conclusion that the best trend line for this would be logarithmic. And of course, if you study chemistry, you'd probably know that's definitely the case. So if we press OK here, we can see here now we've fitted our trend line. I've extended the relationship forward, so maybe I'll just delete that and re-add my trend line there. Make sure I clicked on the data points. Go to add trend line. Go to logarithmic. Here's our options here. Display equation on chart. Okay, here's my trend line with my equation. Just move that down so I can read it. And now we have our finished graph. And so we've also, by displaying the equation on the chart,